Hello, today we're going to learn how to configure wireless settings and wireless optimization. Standalone AP mode is suitable for small wireless networks, home and store, without the need for a separate controller configuration. It is designed for a relatively small-sized wireless network with just a small number of APs to be managed. This mode is designed for users who want to control their APs right away without taking the time to configure a controller, which can simplify the process. In standalone AP mode, each AP can be configured singly by the web browser on its own management web page. Part 1. Configuration Environment Requirements. We recommend that you use Google Chrome. The factory configuration of the AP is shown in the table below. Note: once the AP is connected to the router, it will automatically get an IP address, and the default IP address will be invalid. Part 2. Connecting to the access point. According to the following method, the AP will automatically obtain the IP address after connecting to the router, and the computer will access the AP through a wired or wireless connection. Part 3. Log in into the web management page. Since the AP has been connected to the router, the default management IP of the AP has been changed, so you'll have to use the scan tool to scan the current management address of the AP. Step 1. Install the scan tool on your computer. Step 2. Connect your computer to the AP. Wired or wireless is fine. Step 3. Run the scan tool on your computer. Note: make sure the AP and the computer are on the same subnet. AP tool can be downloaded from the official website. This tool installs on a Windows PC and will allow the customer to detect any AP on the local subnet. The tool will report AP MAC address, name, SN, and IP address of each device on the local subnet. First, run this tool on a Windows PC. Second, select the correct network adapter. Third, click the Scan button to search for an AP. Then, log in to the web page. Step 1. Enter the IP address of the access point in the address bar of the browser to open the login page. Step 2. On the web page, enter the password and click Login to enter the web management system. Default password, admin. You can also check the default password on the bottom sticker of the device. Part 4. Configuration Wizard. Fit AP mode. After we log in the management page, you will get into Quick Setup Wizard. Follow this wizard, we can configure the internet access of the AP. We can take a look on this wizard. It includes 5 steps. The device obtains the IP address through the DHCP by default. Configure the SSID, Wi-Fi password, and the management password. The default internet connection type is DHCP mode. Step 2. In this AP, it supports 2 methods to get IP of the router. Method 1. If the router has DHCP server, the AP can work with dynamic IP mode to get internet IP address automatically. Method 2. If the router assigns the static IP address, the AP can work with static IP mode. After select this mode, you need to type in the static IP address to access internet. Step 3. Enter the DNS address. Generally, the DNS is 8.8.8.8. You can also enter the DNS from your ISP. The above 3 steps have completed the network configuration. The fourth step will carry out the basic configuration of Wi-Fi. Step 4. You can customize basic wireless information such as SSID, which is the Wi-Fi name, encryption type, and Wi-Fi password. Step 5. You can confirm the configuration information. Just click on the Confirm button. Internet and basic wireless settings are done successfully. Part 5. Optimizing wireless performance. Wireless links are susceptible to environmental interference, which may cause wireless link instability, especially for 2.4G radios. It will be affected by many interference from other wireless devices in the environment, such as Bluetooth device, wireless speakers, microwave ovens. In this situation, we need to do some wireless optimization for AP products to reduce the disturbance. First, channel and channel width optimization. Third, transmit power optimization. Before we learn how to optimize, we need to learn about the Wi-Fi radio and the legal frequency in different countries. 2.4G, we can use 14 channels. EU version, support 1 to 13 channels. US version, support 1 to 11 channels. But actually, there are only 3 non-overlapping channels. There will be no interference if they won't overlap. So be careful not to overlap when choosing channels. If there is a wireless signal next to you, choose a channel separated from that signal. We recommend to use channel 1611. Channel width is 20 MHz when deploying 2.4 GHz network. 5G, it has more channel resources, all non-overlapping. Channel width is 20 MHz. With 5G devices matching 5G channels, we recommend using different channels with 20 MHz, 40 MHz, 80 MHz channel width when deploying a 5G network. Figure 2 is a table of parameters. Scanning found that there is already another device using a certain channel. You can change one. The blue part is generally used for radar, so try to avoid. Install Wi-Fi Moho or other Wi-Fi scanning applications on your phone and check the interference analysis result to find the best channel. A suitable solution to reduce interference is for 2.4G radios. Alternate channel is 1611 with a channel width of 20 MHz, HT20. For 5G radios, alternate channel with a channel width of 40 MHz, HT40. The highest peak is the strongest and represents the closest to my device. Try to avoid the peak when setting the channel. The default 5G channel width is 40 MHz. You can change 20 or 80. Go to Advanced RP parameter page to choose the channel and bandwidth. How to change the transmit power. Cloud AP allows users to customize the TX power. Large TX power is not always better, because larger TX power also means greater interference to neighboring APs. In the actual wireless environment, if the distance between adjacent AP is much close, less than 20 meters, it is recommended to decrease the TX power for reducing the wireless interference. For example, if the TX power is 25 dBm, we can decrease it into 22 dBm first for checking. If the wireless connection is still not stable, we can decrease the TX power again. This part is about configuring transmit power. Go to Advanced RP Parameter page. A greater transmit power indicates a larger coverage and brings stronger interference to surrounding wireless routers. In the high-density scenario, you are advised to set the transmit power to a small value. Different devices support different TX powers. Part 6. Configuring the client limit. Go to Advanced RP Parameter page. If the access point is associated with too many clients, it will have a lower performance, affecting user experience. After you configure the threshold, new clients over the threshold will not be allowed to access the Wi-Fi network. Configuring weak signal rejection threshold. Go to Advanced RP Parameter page. In the case of multiple Wi-Fi signals, setting the activation threshold can improve the quality of wireless signals to a certain extent. The further the client is from the access point, the lower the signal strength. If the signal falls below the start threshold, the Wi-Fi will disconnect, and the client will be forced to go offline and choose a closer Wi-Fi signal. However, the higher the kick-off threshold is, the easier it is for client to be kicked offline. To ensure normal internet access, suggested value is -85 dBm. For example, when two offices are connected to two different APs, when the customer walks from Office A to Office B, the threshold value of Office B must be greater than Office A for the customer not to feel the signal weakening. -98, then -88 signal is weak. The signal is weak, easily kicked offline. That is all for today. Thank you for listening. Bye.